All right, here we are at Serverless Office Hours. I hope y'all are doing good. I'm here with Michael. And Michael, I never asked you, is it pronounced rainy?
Yeah, it is actually.
Okay, all righty. Yeah, I got it. Part of my job here is I absolutely slaughter names. So that's one of the things that I do. So rainy, okay, I got that correct. Michael, tell us a little bit about who you are.
Sure. So my name is Michael Rainey. I'm a specialist solutions architect here at AWS. I've been here for about 3 years working with our NoSQL databases, especially the serverless ones, DynamoDB, as well as Amazon Keyspaces, which was launched in 2019 and then GA in 2020. And what we're going to be talking about that a little bit more today. Keyspaces, and hopefully some of the audience here will be new to them, or maybe some users have previously used Cassandra. I have a background in Cassandra, and I've been working with sort of distributed systems for a decade or so, and probably distributed databases for the last 7 or so.
Now, I'll be really honest with you, and I think I was telling you this is I am not now. I used so. When I started, I did a little relational database. I did some MySQL or some MySQL and SQL, things like that. And I was bad at it. I mean, that's just the truth. And then I found DynamoDB, and that's pretty much where I have lived since then. So I'm not a huge, I don't know much about Cassandra. So I was really looking forward to learning from this and seeing, what it's about and how why we would use it. And I know you have some comparisons that you can show. So with that, now if you're new to our Serverless Office Hours, real quick, we do this every Tuesday at 10 a.m. Pacific time, 11 Mountain time, 12 Central, and you do the rest of the math. That's as far as I can go. And serverless. So in this, feel free to ask any questions you want. I'd love for you to throw in the chat. Tell me where you're coming from. Tell me where you're watching from. We have people from all over the world watch the show. So give us a hey, a hello. And like I said, we do this every Tuesday. So I am Eric Johnson. I am a developer advocate for serverless at AWS. I live, breathe, and eat serverless. That's all I do. And so, so this office hours, feel free to ask any questions you have about anything, obviously about the Keyspaces, and we'll turn those over to Michael to answer those questions. And I could do serverless. And looks like we have some folks in from Sao Paulo. Antonio, good to see you. Anyone else throw it in? And with that, Michael, I'm going to throw it to you. Tell us what you've got here.
Yeah, sure. And I just wanted to just comment on what you were saying. I never really was a relational person as well. And I think NoSQL was that handing over that responsibility of the data and the data modeling to the developer. And that's kind of where I started really picking up on, first working with distributed systems, but then really working on distributed state and distributed databases is definitely where I started finding sort of a love for NoSQL and database in general.
So that's a really good point. And I want to expound on that a little bit. So what you're saying, and I agree with you, is when we had relational, usually there was a DBA, right?
Yeah.
They dealt with that schema. They dealt with what that data should look like. Mm-hmm. And very small companies, sometimes the developer was the DBA. I'm sure you and I have both, we've been there. Sure. But in larger companies, when you go to this NoSQL, and NoSQL, obviously, I mean, the name is very descriptive. We don't use SQL, right? NoSQL, but it's less structured. You could say no structure, but it's less structured from row to row, cell to cell, whatever. So there are some differences. Yeah,
absolutely. But that's a breakaway from the DBA, but breaking away from that coordination that you needed to have with that DBA, and the waterfall releases that were built on making sure that these changes all went into safely, and then there's that one person who's responsible for the database and all of these changes.
And that one person dreaded deployments and middle of the night calls, and exactly.
Absolutely. Yeah.
So
all that fun.
Yeah. And it's interesting to me a lot of times when I talk to people and I ask them, what database? Oh, we use MySQL, or we use Microsoft SQL or Oracle or whatever. And the first question is why? Well, because that's what we use. It's like, well, what? And a lot of times it comes out as because that's what we know. And so what I encourage here, and this is the pitch, if you're just watching this, you've not really done this, take a look at what Michael's about to present, because a lot of times we go with SQL because that's what we know. We don't understand the power of one, serverless databases, to this structureless, or this break apart structure that we're going to talk about, and the ability to move very fast. I mean, that's some of the advantages of these databases, is incredibly fast, incredibly high IO. I mean, we power Amazon.com on these kind of databases. So with that, Michael, I've interrupted you when I said I wasn't going to. I'm going to turn it over to you now. So
right. So yeah, absolutely. So today I'm really going to talk a lot about Amazon Keyspaces, which is a Cassandra compatible database service. And Cassandra has been this very widely used NoSQL database for OLTP workloads, use cases that need to scale. Companies that needed early scale, early 2000s and late aughts, really needed to scale for mobile applications and their websites and the growth and the boom of the internet. And again, another common sort of theme I'm gonna talk about is how cool it is at AWS right now is that a lot of you can really leverage that open source ecosystem that we've been building for the past 10 years on Cassandra, or with Kafka, or with Spark. And now there's a lot of serverless offerings that allow you to take that code, take those skill sets, and really break free from, like we were talking about, some of those development challenges, the coordination, the responsibility and the ownership, the isolation, to allow to break free and do agile development, be more innovative. And take advantage of some of those native integrations that we have with the cloud for its security, durability, availability, and then features and other sort of supporting services such as CloudWatch and CloudTrail and CloudFormation and IAM for access and authentication.
yeah.
So really, it's just really going from those stages, from first breaking free from relational databases, breaking away from the coordination of that. And now with serverless, you get to break away as well from the operations, from the management of those instances. Or a lot of these technologies are built sort of on this, let me stand up a cluster, let me throw all my resources in there. Right. And just like our distributed applications, you can get a monolith within a database too. And breaking apart that monolith becomes easier when you have these serverless tooling that you have here on AWS.
So we have a question. Can I interrupt you for a minute here?
Yeah, go ahead, please. Everyone, questions, welcome.
We have this question here from TZ, I believe, and it's an interesting question. I want to make sure we cover it because it's what we're jumping into. And the question is, that's my response, so we don't need to see that. So what is serverless? What's serverless? I always work with RDMS. So I'm gonna answer this real quick in light of databases, and Michael, jump in with me if you want to correct or anything like that. If someone comes and goes, no, that's wrong. Listen to me. So anyway, so what it is, serverless, the idea behind serverless, TZ, is that you do not manage the computers. Obviously, there are servers involved. We don't run this on my mom's refrigerator or anything like that. There are servers, but AWS offloads the management of those servers for you. Let me give you an idea real quick here. So we take care of the patching, the management, and the physical security, different things like that. And so when you want to run a database, all you worry about are reads and writes and storage when you're thinking about serverless database. And so you do not bring up a cluster. You don't have to spin up an RDMS or RDMS cluster. You do not have to spin all that up, manage it. No, now we need to do another regional one. We need to handle the syncing and things like that. With services like this, we manage all that underlying infrastructure, and you just worry about the data. Now I can go more into that where serverless is concerned, and maybe we'll a little later, but Mike, would you add anything to that for service database to that?
For me, yeah, definitely. I mean, for me, is serverless is sort of what the developer needs to manage. It's simply his application, his data model, his logic, everything that is part of what's unique to his application in his business. Is what his concerns are and his ownership and his responsibilities. And everything out of that is sort of managed essentially by AWS. And that's really, again, the democratization of being able to build these massively scalable applications. One developer can build applications that scales for millions of operations per second. And, just 4 or 5 years ago, that would take probably teams of people to do that.
And buildings full of computers.
Yeah.
All over the globe. Exactly. Yeah. So
Yeah.
what happens is serverless, I think cloud in general, but serverless specifically, gives power to developers in a garage, the same power that huge enterprises have, because they have the same access to, like I said earlier, these are the same databases that run Amazon.com, that run our distribution centers, that power Alexa. So they're incredibly high, powerful databases that all you worry about is your data structure. You do not worry about the infrastructure below. And the other thing that I would add onto that, TZ, is that you only pay for what you use. So that's one of the other tenets of serverless is I never have a database sitting or machines out there grinding away that aren't doing anything, that are just waiting for calls. You only pay for a read, a write, or storage.
Yeah, absolutely. So as a sort of a quick agenda today, I'm really going to show, when we say open source, it's not just about the APIs. It's really about taking that existing huge ecosystem that's been growing for 10 years or so or more around some of these tooling and being to re-leverage those in a new way. And also those skill sets, the ability to write against the code against these APIs and really develop those quickly. Is where I see the power and sort of the open source integration, as well as building sort of platform independent stuff. Sometimes you may have a use case where you need to get this application down on the edge, and you may need to deploy some things in some other zone where you don't have availability to some of the serverless stuff. Okay, so really quick. Apache Cassandra, and for those who are familiar with Dynamo and the history of Dynamo, the Dynamo paper, you can really think of Cassandra, and if you see any early talks, you can think of Cassandra really as sort of the Dynamo described in the Dynamo paper, and not the DynamoDB that we have today. And if you really look at any of those early talks from the Dynamo paper, you'll think that you're talking about Cassandra. But generally, what it's been used for is sort of high scale, always available, always on, a lot of redundancy built into it, support for low latency and scalable applications, and common modeling common business problems, user profiles, device metadata. I know the query I want to execute, but I need to execute it 1,000,000 times, and I need low latency and even geographic distribution of that data, maybe across the world. So Cassandra is really one of these technologies you can leverage on-prem or really here at AWS. We've been working with customers running Cassandra for over a decade on EC2. We have set up, best practices and centers of excellences around Cassandra. And really, it's a very powerful technology. And one of the things that developers like, it's the CQL API. And this is an SQL-like interface. And what I think one of the powers behind SQL is that it's a great tool of communicating what you're doing with your query. So if I hand you an SQL query, you get a real sense of what that query is going to do. In some sense, I've seen some SQL queries that will boggle your mind. But when you're looking at single table key value lookups, SQL is night and day in terms of clear. So it's a really effective way of communicating, sharing your queries, etc., and really a really nice tool for data access. So again, some of those challenges, right? Cassandra is essentially a cluster of nodes deployed within your environment. And one of the challenges, right, is all of the tables you deploy in Cassandra generally reside in the cluster. And that, what I was talking about before, was creating a lot of situations of a monolith for customers. And, it becomes, again, when you have a monolith, what you'll have is one person who's then responsible for the monolith and everything that goes on there, because that is one way to centralize and control the development to the monolith, right? So a lot of challenges come out of that, whether it's high latencies, poor configuration, tuning, the sort of knowledge you need from a developer perspective to understand
That's
how
right.
the database works, to use it correctly. To really use Cassandra effectively, you really understand how that query is going to be internalized by the engine, accessing your data, different kind of compaction strategies, etc., that go into that. So there's a high level of skill, and really kind of with serverless, we kind of want to get away from that. We want to democratize the ability to use the database, and we want to provide developers with good isolation so that they can get to the production without impacting the rest of production, and they don't have to do heavy coordination across many teams to get something deployed. So that's essentially what we've done. Is what we've done with Keyspaces is we've created an Apache Cassandra compatible database, but it's serverless. So a big misconception about the service is that we'll be sort of setting up your own sort of cluster for you, and we're sort of managing how you would manage maybe Cassandra, etc. But what we've done here is really we've done a lot of innovation, and we used a lot of the learnings and the technologies that we've built over the past 10 years of providing serverless databases and serverless infrastructure to create this new service that allows you to take your existing Apache Cassandra code, your existing Apache Cassandra drivers, and the open source wealth of intellectual creativity there for 10 years, and go ahead and now transform that into a more dynamic serverless environment where, like you were saying, Eric, you get to provision and pay for what you exactly use. You have this fully managed capability to create a table in a few seconds, but then be able to scale that up to millions of operations per second without needing an entire team. And guarantees sort of the performance at scale. So whether you're requesting at 10 requests per second or 100 million requests per second, you should have similar latencies for those key value access patterns. And then again, built on sort of AWS expertise of providing a high 4 nines of SLA, as well as built-in end-to-end encryption, etc. So that you're fully secure and compliant with your applications, so that you can go ahead and get to production quickly, and know that your data and your customers are safe. So some of you may be familiar with DynamoDB and DynamoDB modeling. So I just wanted to touch a little bit on the Dynamo to Cassandra sort of comparisons and modeling, so that you get an idea of, this is very similar. One of the fundamental differences is that Cassandra is a schema on write and DynamoDB is a schema on read. So actually, when you're creating your tables in Cassandra, you're going well beyond just the partition key and a sort key. You're going into the what you would call items or attributes in the DynamoDB sense, where you can actually strongly type some of those attributes to specific types, and that each one of those items or rows in Cassandra would have the same sort of schema to them.
Interesting. Okay, I've never heard it put this way, so I want to make sure I understood you. Okay.
Yeah.
So schema on write, meaning when I create the table, I'm creating some schema, or are you saying, are you saying when I create the record?
Yeah. So when I create the table, I'm defining a schema for my NoSQL data. And that schema will be validated when you write the data or insert it. And if you didn't, it does not follow that schema, that write will be rejected.
Interesting. Okay.
So,
Right.
you know,
So
you
whereas
get that, right?
Dynamo, I usually just do here's my ID, and then here's just a ton of data, and it looks different every time. So that is a different approach. Very interesting.
Yeah.
Okay.
So yeah, in Dynamo, the schema is more within it's distributed.
That's
It's
right.
within the application teams. It's within the mental model that you have for that table, and you know, so that it's just a little bit more strongly typed than Cassandra, but it is semi-structured. It's pretty easy to add new fields. You can have sort of unstructured data such as or semi-structured data such as maps and lists or sets, etc., where you can provide more if you want some of more the schema flexibility to create things that are, let's say, you know, different rows may have different values. You have the capability to do a little bit more of that, the schema less aspects to your data model as well, so you can sort of kind of blend them in a hybrid way.
That's really cool. So it's almost like Apache Cassandra is somewhere between Dynamo or Mongo. That's another one that we talk about a lot of time, and like a sequel. So it's kind of maybe a best of both worlds kind of idea.
Yeah, I'd say like from a non-functional use case, like, you know, very sort of key value access patterns, scalable, low latency. It's extremely similar to Dynamo. From a modeling perspective, again, still you'll follow a lot of the same design principles, such as like having a good or high cardinality partition key.
Sure. Sure.
You can, you know, have a sort key, or we call it a clustering key in Cassandra. But essentially, if you want to add more data to that partition to improve, you know, increase the number of access patterns you want to have on that data.
Okay.
And again, you know, you won't be able to do things like light queries or fuzzy searches or, you know, free form kind of searches. When you're designing your model, you kind of want to know what you're going to look up and how you want to look it up.
That's right. You understand your data and your access patterns.
Mhm.
That's the same with
Yeah,
anything. Yeah.
right. I'd almost, maybe it's similar now to Particle and Dynamo,
Okay.
except that Cassandra will also centralize that schema for you.
Okay. So real quick, and we have a question coming in. I'll speak
Yeah.
to you. It says, can you explain partitions with an example?
Yeah, so a partition. So imagine that you are looking to scale your website to millions of users per second. To power that, you essentially want to be able to distribute that work over a lot of different machines. So a partition key allows you to define a field in which the data will be sort of distributed based on that key, so that the better or the higher cardinality of that key, the more unique that key is, the better the distribution for that access, and the better utilization you have of your resources. So to make use of a large scale, the resources that, you know, Keyspaces is going to provide you, there's a little bit of correlation with, you know, understanding that you also need to distribute your data well and have some good keys that are going to scale.
Yep. Yep. That makes sense. So you're spreading across multiple partitions, divisions, machines that can look
Yeah.
like several different things, but it's the idea of spreading that data out. So you're not reading all from one place, one machine, two machines aren't doing all the work. It's being pushed out, and we use that
Yeah.
across a lot of different. And it's called different things, but kinesis.
Mhm.
You know,
Shard key, yeah.
yeah, exactly, sharding. We use that kind of technology across a lot of different services because I'm just going to say it's going to sound
Yeah.
kind of arrogant, but we know how to be distributed. I mean, that's something we learned, and AWS is very good at distributed technology. So.
Yeah, and
Thanks for
definitely
listening.
important to distribute it. One of the fundamental, you know, things as a developer, you're really not going to be able to, you know, get away too far from, but you can always have to choose some good partition keys, so that one, you can answer the questions that your queries want to get the data that you need, but you also have to do it in such a way that you're not using the same key for every query, and that you don't create hot partitions and hotkeys.
Right.
So cool. There's some features I at the bottom there, these are features that Apache Cassandra has, but Keyspaces currently does not support. So some of these features as an open source project are not generally, don't meet the quality of scale to provide it as a serverless, provided in a serverless way. We're looking to implement these in the long run. But when we do, we're going to harden them and make sure that they're easily to use for customers and that they're scalable. So what I think I should do is I should probably jump in maybe to a little bit of a demo too, and then we can maybe jump back a little bit into modeling as well.
That'd be
but
great.
let's I just want to show, like, so there's going to be sort of 3 ways that you start working with Keyspaces to take advantage of a serverless database. You may have sort of an existing tools that you want to switch from Cassandra to Keyspaces. So you want to leverage that existing Cassandra ecosystem. You may want to maybe use some of those, move some of the stack, like I was showing before with MSK, Glue, Keyspaces, Fargate. A lot of technologies related in your stack probably could be moved and used jointly in a serverless way. So I'll show sort of multiple serverless technologies working together. And then finally, some native integration. So things that, Keyspaces just provides out of the box, such as, point in time recovery, monitoring, and dashboarding, etc.
All right. So while you're setting up, I'm going to answer a question real quick. We had a question from Captain Christoph. Christoph, how was Apache Cassandra used on Prime Day? So actually, DynamoDB was the NoSQL that was used on Prime Day, as well as many other serverless technologies. A lot of serverless technologies were used there. And I posted a link, Prime Day Tech. And this Jeff Barr, our chief evangelist, writes this blog every year. It's really interesting to see what that's done. But you can see what different tech was used for Prime Day to handle the kind of traffic.
Yeah. Right. Yeah, absolutely. There is definitely a lot of customers running Apache Cassandra on AWS and EC2. And obviously there you could check out a few blogs with some customers who have adopted Amazon Keyspaces, and we've partnered with in blogs customers like Intuit, William Hill, and SumUp. We all have either white papers or blogs that you can go ahead and look at how they're using Amazon Keyspaces today. So I'm just going to connect to EC2 console in EC2 instance. Kind of what I want to do is really just use some existing Cassandra tooling to go ahead, log in, open a session with Amazon Keyspaces, and create a new table, and then load some data into the database. So one of the resources you could check out is the Amazon Keyspaces Immersion Day workshop. And you can go through here, and there's a few tutorials on how you can do some basic stuff with Amazon Keyspaces. And what I'm going to do is just go quickly and set up sort of what we have for our sort of SDK. So the AWS SDK supports Amazon Keyspaces, but from this perspective, we're using existing tooling. This is tooling that customers probably are using in their applications with Cassandra today. So really just going to do a pip install on that. Hit this init script here. This is a special build that we have of this software that sort of integrates well with IAM. And what we're going to do is just connect Amazon Keyspaces using a program called CQSH. Okay. You can see that we've connected to Amazon Keyspaces in US East 1 here, using a SIG-v4 authentication plugin, which is using short-term credentials to gain access based on an IAM role. You can see that the current consistency level is 1, And you can think of a consistency level of 1, if you're not familiar with Cassandra, is eventually consistent. So we want sort of low, strong, consistent access or data operations in this exercise. So I'm going to change it to consistency level as local quorum. And what that's going to be able to do is make sure that when I write data, that it's durable and consistent, that all readers will see that data.
Hey, Michael, can you blow that up maybe one?
Oh, yeah, sure.
Thank you. And if you're having a hard time seeing it, go ahead and post something in the chat, and we're glad to respond. Oh, that's plenty big.
Much.
That's probably huge in your face.
View.
Yeah. Yeah, there you go. Yeah. It's always fun when you're presenting, and because on your screen it's like, whoa, it's right here,
Yeah.
but we know we make it big enough. So
yeah.
Yeah. And I've posted all the links you referenced, the workshop, as well as the Intuit use case. I posted links for that. So if you're in the chat, yeah, if you're in the chat, grab those. We've also got some other questions coming in that we'll jump to after Michael shows some stuff here. So
yeah, absolutely. So what I'm gonna first you do is you're gonna create a key space, and you can think of a key space as a collection of tables. So Dynamo, the basic unit of abstraction is a table, and very similar key spaces. The basic unit of abstraction is a table as well. You're dealing with these tables. There's no joins between tables, etc. But with Cassandra, there's a concept of a key space, which can sort of group tables into a single key space. And you can do things like, make sure that access is controlled by a key space security-wise. When you get to a multi-region sort of topology, you can actually configure multiple tables to be global as well. So there's like properties in the hierarchy. There's properties that you could specify at a key space level that will essentially affect all the tables within that key space. A lot of times customers will also use it sort of kind of like a multi-tenant strategy. Is like I might isolate different clients and customers by key space. So again, you can apply AWS tags to this key space, and you can go ahead and figure out things on the Cost Explorer, or you may do things with IAM security policies to go ahead and configure that.
Okay, so I'm going to ask you a couple of questions really quick here. So what you're creating right now is what we would call a table, right? You're calling it a key space, but it's a table.
No, it's kind of like it would be like a bucket of tables, and what I would do next is then create tables within that key space.
Gotcha. All right. So, and when you say class single region strategy, this is identifying. This is just going to be a single region that these will live in. Okay, I got it. And then these are just tags on the bucket of tables.
Absolutely,
right.
Absolutely.
Got it. Okay, cool. Now you're going to start throwing tables in. Got it.
I'm going to be throwing tables at you right now.
We're going to get crazy.
Yeah. Cool. Yeah. So what I'll do is then I also want to create a table, right? And it's going to be, and you do this, again, there's multiple ways to do this, whether it's through CloudFormation or through the console, but I'm going to use the classic way that we use with Cassandra, and that is a create table statement. And it really looks like a traditional SQL.
Yeah, it does.
Create table, right?
So, what little I know, I mean, come on, I'm not sure.
Yeah. Right.
Okay.
So, see that Twitch demo key space, and my table is smoke test. Smoke test is a primary key of an ID and event. And you can think of this as my partition key and my sort key if you're coming from a Dynamo world. This in Cassandra, it's an ID and a partition key and a clustering key.
So two of those together make it unique.
Yeah, and so those together make a unique row or unique item.
Got it.
So I'm going to create the table. And one of the differences with serverless is that this table is being created asynchronously, right? When you have a Cassandra cluster, you create a table. It's a synchronous event. It's done instantly. But that's it, because you're limited to the resources of that cluster. But with the serverless way, this is creating this table sort of dynamically and go ahead and get those resources for your table, etc.
Okay. So you fire and forget it. So you've sent it out to create,
Yeah.
and now you can start adding. Got it.
Yeah, start adding
Okay.
stuff. What I'm going to do is a little, sorry. Oop. All right, I'm going to go ahead and I'm just going to do a dump, right? And I created a file called smoke test. It has 50,000 lines in it, including the header. And what it is just, again, it's just some data that I'm going to dump into this table. So you could see that I partition key, sort key, data for that row, right? So some simple data that we're going to load. And really the point is to just demonstrate some of this existing Cassandra tooling and how users would sort of interact with Cassandra, but now we're kind of doing this in a serverless way. All right, so let me go ahead and just connect back to Keyspaces. And console is going crazy here.
You know why? Because people are watching. This is how live demos.
Why would not?
If we weren't watching, this would have no problem.
Oh yeah, absolutely.
Oh man, thank goodness for bash history.
Yeah, I love it. I didn't use grep, so I'm sorry. No time for grepping.
There you
go. Consistent. Yeah. I'm gonna set my consistency back to local quorum. All right. And then I want to kind of load data into this table. But first, I just want to make sure that my table is created. So I'm going to describe table very SQL.
You're missing an R in your describe.
Oh, all right. Hey, come on. You got to let my demo fail.
Well, you know. There you go.
All right.
I got your back.
Thank you, sir. All right. Now I lost. Okay. Describe table. Twitch demo. Got smoke test. And I'll see my table. You'll actually see here, there's a ton of settings and configurations. None of these apply anymore. This is all legacy stuff from what you would have to configure and tune when you were working with Cassandra. You know, try to get this right as a developer and then share that across multiple application teams working on this. Very, very difficult thing to tune and get right for performance sake. But
so can I ask you a question about that? You say none of that applies anymore. Is that because we handle it?
Exactly. We take care of this stuff.
So these are the settings we set to make it work properly.
Yes.
So that you would normally have to wrestle with. Got it. Okay, cool. Thanks.
Right. So this is all you have to care about, right? As a developer, right? Was talking about not only separating out the operations, right, but just setting the freedom of sort of let me as a developer focus on my application and my use case, right? So this table's ready. Described it to go ahead and use. And what I'm going to do is go ahead and use this tooling here to just copy this data to the table. And it's going to copy this. I think one of the differences too when working with serverless, you work a lot more with limits and rate limiting, right? Versus traditionally with an instance-based technology, you probably just throw everything at it at once and just let the CPU increase until everything slows down to a halt, right?
Right.
With serverless, DynamoDB, Keyspaces, when you create a new resource, it doesn't really know the throughput that you're going to throw at it. It needs time to bring in enough resources. It sort of builds itself out based on a history of traffic. And until then, if you request too much too early, you can hit some sort of throttles and you'll get some errors back, which, then you got to retry or, put it into a rate limiter. So with level 200, when Eric invites me back, we'll get a lot deeper into how do I make sure that I have enough serverless capacity for my database.
So with DynamoDB, and you'll probably cover this the 200. In DynamoDB, I can manually set I can say, look, I know I'm going to have 300 writes per second, 500 writes, whatever. I can manually set those. And so we provision it, it's ready to go.
Yep.
But and normally the one I use is the dynamic, which is what you just said, where it learns your pattern and expands and comes back or expands and contracts is the other word as needed.
Yeah.
So does Cassandra or does the Keyspaces have the ability to manually set those as well?
Yeah, absolutely.
Okay.
So you can go ahead and either provision a certain amount of traffic that you think that's going to occur, and use some sophisticated, auto scaling to, increase that rate dynamically
Gotcha.
based on your traffic. Or you can go ahead and create a new on-demand table, which I just did here, which is
Yeah.
the default in Keyspaces, which is going to base capacity based on a history, and kind of continuously increase that. I kind of think of it as almost like a balloon. The first time you blow up a balloon, right, it takes a little bit more. It takes a little effort. It has the balloon needs to learn how big it needs to get, right. But the next 3-4 times you blow up that balloon, the second or third time, it's a cinch, right. So
got it. That makes sense.
Similar with the sort of NoSQL databases, it needs to learn your traffic patterns, which is great because once you get in production, it continues to learn, it continues to adapt, it continues to improve the access patterns and the availability of resources for to account for when the things that you did not expect happen. So having that sort of capability of sort of constantly adjusting it is definitely new to would be new for Cassandra developers, which more or less had more of a fixed infrastructure.
Right.
Cool. So now that we've go ahead and loaded some data, we use the tool. We can go check it out in the Keyspaces console. Off the bat, you'll have some metrics on it as a dashboard. But I'm going to check out my Keyspaces and look for this Twitch demo. I have my AWS Twitch table smoke test. It's an on-demand table.
You can probably bring that size down a little bit if you need to for you.
Maybe.
It's pretty big. There you go. That's perfect right there.
Okay, yeah. And so we have this smoke test. We could see that we're writing some data, but it doesn't show in CloudWatch yet. But we can actually execute SQL queries right from the editor in the console. So you go ahead and execute some queries. You'll get some response times, and you get a nice tabular view or a JSON view of your data. So you go ahead and not only work on and build your queries that you need for your applications, but you go ahead and do some data exploration right here in the console. And again, you can see that all these columns are not only have their names, but they are probably strongly typed as well as strings or ints, etc. So cool. Yeah. So let me. Any questions?
Yeah. I was just gonna say. So we have a clarification that was asked for, and if you want to jump on it, I can. I thought the partition keys. So let's go back to our earlier question. I thought the partition keys are used to locate the nearest node. That might result in lesser lag. Correct me if I'm wrong, by the way. Brand new to NoSQL stuff just today. Good job. Way to be adventurous. Stay with it. It absolutely has its value. Right tool, right job. So I don't know, Michael, you want to jump on that one? Or you want me to handle it?
Yeah. So I'll have to maybe go back in history here. So Apache Cassandra, really a lot of the database services today will separate compute and storage. And traditionally with Apache Cassandra, you didn't have that. You have a node, and that node is your unit of scale. And that node does everything from request routing to load balancing, as well as persistence, data lookups, backups. It does it all, right? But when you didn't have great orchestration tools on-prem, and scaling can be challenging, it's great to just have one thing that you need to do and one thing you need to worry about. So again, this partition key is used. Yes, it is used for routing to the nearest node to connect to and query for the data. And that's done today as well. But again, the partition key helps you locate this data quickly. But again, a lot of times with at least with Amazon Keyspaces, we handle a lot of the connecting to the right, essentially the right node, or the routing and the load balancing, etc. What you really want to care about that partition key is the lookup against the storage layer, which will be sort of answering the query that you want it to be answered. So if I want to, if I'm building a shopping cart application and a user comes back into the session and he wants to get his cart, well, a good way to store that data would be by the user ID, right? So that the user can look up the cart based on his user ID. And that's going to be unique to all users. And it's going to be fairly distributed because of the consistent hashing algorithm that's going on the storage layer. So hope I was able to get that. It's not maybe a succinct answer, but the partition key is used for both the distribution of data, the distribution of the access to that data, but also being able to look up that data. So there's essentially three things, maybe even more, that the partition key is fundamental to in modeling your NoSQL data.
Yep. And I just posted a how it works in our docs. We have a how it works that might explain some of that. But one other question, and just so we can clarify, is does AWS have a Cassandra-like own managed service? And it does. That's what you're looking at right now.
Yes.
So Keyspaces is a managed service that is compatible with Cassandra. So just to kind of be clear on that, Antonio, you were asking that. So hopefully that clarifies that.
Yeah, just a little bit into that. Like if I go into now, I'm going to query. I'm messing my syntax here. I'm going to look up. I'm going to say, get me my endpoints, right? And what Keyspaces, how it presents itself to the existing Cassandra driver is essentially anywhere from a 3 to 9 node cluster, but essentially those are more or less load balanced to a huge fleet of infrastructure that's going to process your request. So here's a nice diagram here. Those endpoints that you saw is this service endpoints where you're connecting to. You'll be routed to your request routers or query processing, which is going to interpret your query. And then it's going to be able to look up and store that data over multiple physical resources across multiple availability zones. So you get this super redundant, low latency architecture, out of the box.
So that interesting here. So we handle that distribution, right? So when we look at, okay, you write it, then we're going to handle distributing that data across multiple zones. This is how we do the same with Dynamo. We do the same with Serverless Aurora, where you have this replication of your data. We handle quorum. It takes that now, and this is an eventual consistency model as well, right?
Well, it's either or. So when you write data to Keyspaces, we're going to make it durable and consistent. So we'll write a 2 out of 3 replicas of the data. Now, if you want to save cost on your reads, you can do eventual consistent read, which means that it will just read from one of the 3 replicas there. And essentially for doing an eventual consistent read, there's a 2 out of 3 chance you get the latest data, but there's a 1 in 3 chance that data might be behind by a few milliseconds. So you can use eventual consistency on reads in Keyspaces, but all writes will be durable and consistent.
Exactly. All right.
Okay. So quickly, I'll get to is as we're kind of rounding down on time here. We looked at open source, the open source ecosystem, and using those existing tools. But now it kind of like I have code, I have an application that I wrote, and I want to sort of, what can I use from an AWS perspective to build in a serverless way for my entire stack? Well, like I kind of was pointing to in the beginning, now, we have AWS Glue, which allows you to run a lot of your Spark code
Right.
in a serverless way. We actually have serverless EMR that's coming as well. And we have serverless Kafka, managed Kafka service as well. So a lot of these open source technologies now you can start using a lot of your open source ecosystem with. As well as in Keyspaces. And I find that a lot of times there's a parity is users who are using Keyspaces are generally using sort of, Kafka, and they may be using Spark and Glue, etc. So there's going to be a lot more, there's going to be a lot of resources available to you in terms of GitHub, sample coding, and stuff like that through the ecosystem. And then again, we're going to continue to build out these integrations so that it's much easier to connect these things together. So what I'm going to do is just show sort of like how I use Glue using an open source Spark connector. So there's an open source Spark connector that's been around for a number of years that people have been using with EMR forever. Not EMR, well, EMR and Spark to sort of do distributed activity with Keyspaces. And if you've ever worked with NoSQL, you're gonna need Spark. Now, Spark is not just for sort of analytics, etc., but you're gonna need to do things like fix a field across your entire table, or do massive exports, do transformations, do daily loads. So there's a ton of uses for Spark and NoSQL that just allow you to do large scale management activities across your data. Again, we're going to use serverless Glue for these functions, and we also have a few different examples on GitHub. If you go to Amazon Keyspaces examples, we have a ton of examples that will be used to either count, export, or even copy data from Cassandra. So you can copy data from your Cassandra instances to Keyspaces using Glue. So what I'll do quickly, I guess, I think we're running out of time. I'll just have time to launch it or just show you how I can do it. So I'm just going to go to Glue. And I have existing jobs. You might be running these jobs multiple times, right? And I have my, I think it was this one. Maybe it was this one. It's one of these.
Fun.
Yeah. All right. So essentially, when you create these Glue jobs, you have a script. And it's just a simple Scala script using all the open source code. This may be an existing open source application. Nothing really specific here to AWS. I'm creating a data frame by reading the Cassandra table. And all I'm going to do is to count the rows of that table. And this is commonly used, like you've just loaded data into the table. Now you got to figure out how many rows you have in that table, how many items you have in that table. So this is simple, just a way to, instead of setting up an entire cluster to run this job, you can essentially execute a Glue script and, allocate a few Glue cores and pay for only what you use here. So only takes for this script, it only takes a few parameters. You have the key space, which was Twitch demo, and then you have the table name, which was smoke test, and that's it. And save it.
Sorry, I'm having some kind of coughing attack on this side of the screen. Sorry about that, everybody.
Looks like I'm currently running too many jobs in Glue. Better check out my AWS
Your limits.
Yeah. All right. I wasn't thinking I was going to get out of this session without crashing a demo, but that's what that's the fun of it.
So what we'll do, and Michael, we do this a lot because this is live demoing. What we could do is Michael, if you'll post to Twitter later, just saying, hey, here's what it was. We fixed it. I did post a link to the Amazon Keyspaces examples.
Perfect.
So they can jump in and do these and run them themselves. But here's what I encourage you. I mean, so if you are a Cassandra user now, And Antonio and I were talking on the YouTube channel there a little bit about, don't people have to build up clusters? If you're running a cluster to maintain a Cassandra database right now, man, you need to drop that. Get into the managed service. Get out of that cluster management job and get into managing your data and building your app. I really encourage you to do that. If you're new to NoSQL, Cassandra's a great place to look. DynamoDB is a great place to look. I really encourage you to see, again, get away from, we use SQL because that's all we know. I encourage you, especially in a serverless world, and Michael's explained a lot of the reasons why, but especially in a serverless world, you want to get away from SQL unless you need it. Again, right tool for right job, and there are some times when you need relational databases, but I would evaluate that heavily. And if you're looking for, I want to understand this more. There is if you look up Rick Houlihan at AWS or the AWS summits or reInvent, he talks a lot about NoSQL versus relational databases and single table patterns and different things like that. And I'll ask you this, Michael. I'm sure you've heard those conversations. Single table patterns, is that something that's as important in Keyspaces, or would you push that in Keyspaces like we talked about in Dynamo, or do you see more multi-table patterns? Because it looks like with the namespace, multi might make more sense. I don't know.
Yeah, I think that it's the right model for the right job. I think there are ways to implement sort of single table design by using sort of generic keys and generic attributes for your rows in Cassandra Keyspaces. But I'd say that historically, a lot more customers will use and existing Cassandra users use more of a table per sort of access pattern sort of design, or a table and multiple access patterns, and allow Keyspaces to handle a lot of the multi-tenancy and resource pooling on its side. So it definitely can be a pattern that you can use. But I'd say just from a broad adoption standpoint, I think most Cassandra users go with multi-table.
Okay. And that may be because like I said earlier, it kind of has that mix of some of the SQL, especially as you're setting structure on the write instead of the read. That makes sense to me. So, all right.
Yeah,
I do want to. Sorry, go ahead.
Yeah, absolutely. It's I'm open to explore. I want to see what AWS now with it being serverless, and there's going to be a lot more experimentation with the database, because again, you're not going to blow up the rest of production using this like you would with Cassandra. So I want people to go ahead there, break the rules, and come up with new models and new ways to use Cassandra. That's essentially the point of the service. So, and
let us know. Our Twitter handles are right here. Let Michael know. If you have questions, reach out to us. I fully admit I don't have all the answers, but the cool thing about working here is a lot of times we know the people who do. So we're glad to help out. I do want to do a shout out to, is it Sri Rathan 10? Is that your partner in crime that's helping out?
Yeah, specialist here at AWS, and you're probably helping out on the chat there.
That's right. Sri actually beat me to some of the links. Well done, sir. So we're throwing that out there, and I appreciate that. And with that, I'm going to sign us off. Michael, I really appreciate you coming in and helping out. This was super helpful. We will definitely do a 200. There you go. Next week, we're going to be doing DynamoDB misconceptions. We're going to stay in the database theme. Mr. Alex Debris will be joining us.
Oh, nice.
If you haven't heard that name, he is a database stallion. He really is good at it. All around nice guy. And so I encourage you to check that out. And with that, we'll see you later. Again, thanks, Michael. Thank you, Sri. And we'll see you later.